Hi, welcome to Dissolve Chemistry. Let us continue with our mission 70. So, in the previous video, we have discussed numerical problems on solutions. So, in the present video, we will go with a very important MCQs which I have framed for you. Okay. So, let us continue with the multiple choice questions. As already we have said, in solutions, the two questions will appear 1 mark questions. In that, probably both may be MCQs or maybe one will be fill in the blank. Okay. So let us start with these MCQs. Okay. First we will take in countries nearer to polar region, the roads are sprinkled with calcium chloride. Is the options given will be to minimize the wear and tear of the roads, to minimize the snowfall, to minimize pollution, to minimize the accumulation of dust on the road. So actually calcium chloride is added to lower the melting point, freezing point of water. Okay. So when the snow falls on that calcium chloride, then what happens? It becomes a solution of non-volatile solute. So hence what happens? Its freezing point is going to decrease. So as the freezing point decreases, then what happens? Whatever the snow falls on the road be what? Converted into liquid water. Hence we can avoid snow over the road. Right? So why it happens so? Because of lowering of the freezing point of the water, right? So therefore the option will be 2, to minimize the snowfall on the road. Let us take the second question. Okay, according to Raoult's law, the ideal solution have. Okay, so here you should remember that what do you mean by this ideal solution? Solution which obeys Raoult's law, partial pressure of A, and that will be always equal to P naught A into its mole fraction, right? So if the interaction between A and B in the solution are as good as between A in pure state and B in the pure state, so therefore then what happens? It will be acting as what? Ideal solution. So therefore for ideal solution, the enthalpy of mixing, and change in the volume, always it will be 0, and entropy of the mixing, always you should remember it will not be equal to 0. So therefore if you look into the options, so therefore enthalpy of mixing is equal to 0, and change in enthalpy, change in volume 0, and change in entropy is not equal to 0. So the option will be what? First option. Then next move on to the third question. So when the soda bottle is opened, the CO2 gas fizzes out because, what is the reason for this carbon dioxide gas will come out of it, or fizzes out means which will burst out from the bottle? What is the reason for that? So the option given are carbon dioxide gas is packed at high temperature, carbon dioxide gas is packed at high pressure, and when it is opened then pressure decreases. Carbon dioxide gas is packed at so we can make this both repetition is there, packed at lower pressure, you can make this. So carbon dioxide is unstable in water. So like that 4 options were given. So in that your correct option will be what? So always remember it is in relevance with your Henry's law. So the gas can be made to solubilize in any liquid by applying the pressure. We know that one. So more amount of the pressure if you apply, more amount of the gas will get solubilized in aqueous medium or any liquid solution, right? So this is how we can mix it, or we can make the gas to dissolve more in liquid phase. So therefore, when you open, so initially it is being packed and closed at high pressure, okay, high pressure. Then when the soda bottle is opened, so then what happens, automatically your pressure, say for example it is being packed at 5 atmosphere. When you open it comes to what, 1 atmosphere. As the pressure is lowered, the gas already dissolved in the liquid phase will come out. Okay, that is nothing but what, fizzing out of the gas we call. And that happens due to what, carbon dioxide gas is packed at high pressure, and when it is opened then the pressure is decreased, gas will start going out. Okay, hence it fizzes out, right? So that is how we have to give the reason for that, right? The next question is, so for deep sea diving by scuba divers use oxygen gas in a cylinder which is diluted with helium because. So first thing you should remember that scuba divers means those people who are diving in deep sea. Okay, so in that what they will do is they are going to use oxygen cylinder. Okay, for respiration purpose they will carry the oxygen cylinder. Usually that oxygen contains oxygen as well as nitrogen. If this nitrogen content is high, so then what happens when they go into the deep sea? Okay, so when they go into the deep sea, then what happens? So the pressure will be high at the deep sea. Okay, so pressure increases, due to which what happens, the nitrogen gas respired by the scuba divers will be high. So therefore more amount of the nitrogen is accumulated in the blood. Okay, and when they come up, okay, so onto the surface of the sea, so then what happens, this nitrogen gas all of a sudden as the pressure decreases it will start moving out as the gas is fizzing out from the soda bottle. So during that what happens, there vacuums are created in the blood vessels, and these vacuums leads to what, formation of the bends in the blood vessels, and that leads to what, a lot of strain or pain in the is being faced by the scuba divers. So hence instead of this nitrogen, the concentration of the nitrogen is decreased, or oxygen is diluted with what, helium. You should remember this reason why it is being this helium is being used to dilute, right? So your option is what, nitrogen is highly soluble in blood under deep sea, so solubility decreases at the surface and causes bend. So therefore for this particular reason it is being diluted with helium. Okay, so this is the fourth question. Next let us move on to the fifth question. The colligative properties are, first we will read out the options. The properties of the dilute solution and does not depend upon the number of molecules. Okay, the properties of the concentrated solution and depend upon the number of molecules. The properties of the dilute solution and depend only upon the number of molecules. These are the properties of both concentrated and dilute solution and independent of the number of solute molecules. Right. So now we will talk, I will define what colligative property is, then you make out which option is correct, right? So the first thing is, colligative properties are the properties of the dilute solution. First thing you should remember are the dilute solution containing non-volatile solute. Okay, generally solid solute we can call. And dilute solution, first point I have already covered. The second thing is that these properties are dependent on the number of solute molecules. Okay, but not on the nature of the solute molecule. The solute molecule, it is maybe molecule, maybe ion, maybe atom, whatever it is. Okay, it is least bothered about its nature. Either only it depends upon how many number of non-volatile solute molecules are there in the solution, that decides the property. So therefore, which option is correct? First point already I have said, properties of the dilute solution and depend only upon the number of the molecules. So therefore your option is third option. Properties. What are colligative properties? Relative lowering of the vapor pressure. Okay, then elevation in boiling point, depression in freezing point, and osmotic pressure. Okay, you should remember these four properties are referred as what? Colligative properties. Okay, so next we will move on to the next question. Sixth question, the molecular weight of solute compound determined from colligative property is high compared to actual molecular weight. Okay, so suppose molecular weight of the compound, for example, you assume it is 100. Okay, we are expecting this to, or it is actual molecular mass of the compound. But when we determine this, okay, so when it is determined by using colligative property like relative lowering of the vapor pressure, or from elevation in boiling point, or from osmotic pressure, it is found to be higher than this, means greater than 100. Okay, so then when the molecules, when you dissolve in the solution, okay, so if its molecular identity is, or its whatever the nature is there, so that nature, if it sustains in a solution also, then there is no question of change in the molecular weight. Okay, whatever we get molecular weight from colligative property, what happens, it will be same as good as its expected molecular weight. But when the two molecules will associate with each other, dissociate to give, one will dissociate to give two molecules. Okay, so 2, 3 or like that, if it undergoes dissociation and if the number increases, already we know that colligative properties are dependent upon the number of solute molecules or ions, whatever it is, components we call. But it won't depends upon what? Nature of the compound. So therefore, always remember this colligative property. Okay, colligative property is inversely proportional to molecular weight of the solute. Okay, so therefore, if the molecular weight is high, means what? Your colligative property is low. When the colligative property is low, meaning is what? Number of solute molecules are less than actual, what we consider. So less means what? This is only possible when the two molecules will associate to give single entity. Okay, so therefore your option will be what? It is due to association of the molecule in the solution. Okay, so I hope you have understood this one, right? Next, move on to the next question. The seventh question. The solubility of the gas compound in water can be enhanced by, already we have seen in the last question that on carbon dioxide, right? So that increases by the increase in pressure. By increasing the pressure, we can increase the amount of the gas, either maybe in water or in any solvent. By decreasing the pressure, by increasing the temperature, by decreasing the temperature. Of course, decreasing the temperature is also one of the option, but compared to this option will be more appropriate. What is the reason for that? Pressure has a lot of impact on the dissolution of gas in given solvent, maybe water or any other gas. Okay, so your right option is what? A1. Okay, so next question is, the molality of the solution is defined as. See here, I have taken this question because we will discuss a very different aspect, but we leave the silly things and that you are going to be left out. So because of that reason, I have chosen such questions. The molality of the solution. See here, molality is one of the way of expressing what? Concentration, right? So molality means, see here, number of moles of solute to make 1 kg of solution. Okay, so number of solute per kg of solvent or solution, we call it as what? Molality. So that is how we are going to define this one, right? Molality, how it is defined? Number of moles of solute present in 1 kg of solution. So that we call it as what? Molality. So here options, how it is being given: number of grams per liter of the solution, number of grams per kilograms of the solution, number of moles per liter of the solution, number of moles per kilogram of the solution. Okay. So here So the fourth option is number of moles per kg kilograms of the solution. So that is the right option you can choose, right? So next move on to the ninth question. The ninth question, again same, we have taken the molarity of the solution is defined as, apart from this, okay. So still other questions on like in relevance with expression of the concentration of the solution, like parts per million they may ask, okay, percentage composition they may ask, on mole fraction also they may ask, right? The molarity of the solution is defined as molality is defined that as number of moles of solute per liter. Here in terms of volume we take, there we are taking in terms of what? Kilograms. Okay, mass we are going to take. So 1 liter of the solution or 1 dmq. Number of moles of solute per liter of solution, then it is called molarity. Number of moles of solute per kg of solvent solution, we call it as what? Molality. Okay. So therefore your option will be what? Third option, right? The next 10th question we will take. So binary solutions are the, binary word itself is saying two components. Okay. That two components may be what? Liquid solid, or whatever it is. One will be solute, another will be solvent, or two components. If it comprises two components, then it is called as what? Binary solution. Solution containing two components are called binary solutions. So here the option given are the solutions which contain two solutes dissolved in water. Two solutes means like sugar, salt dissolved in water. Is it going to be? It is a ternary solution, means three components will be there. So it is not the option, right? Next, the solution of two or more components. Two or more means what? Once again, it goes beyond 2. So therefore what? It is also not the right option. So then the solution of any two components, as I already mentioned, okay, any two components, solid, liquid, gas, whatever it is, two components are there in that, including solute as well as solvent, then it is called what? Binary solution. So therefore your option is third option. Let us move on to the next question. Which of the following liquid pairs show positive deviation from the Rolle's law? See, first one thing we should remember, what this positive deviation and negative deviation, these are called non-ideal solutions. Non-ideal solutions are of two types. One showing positive deviation. Why they show positive deviation? Just I will illustrate. See here, you take two different types of solutions. Three we will take, right? One solution which contains AB. This is also AB. This is also AB solution. Okay. So now, if the A and B, when they are mixed to form the solution, if they have the interaction as good as when they are present in the pure form, okay, BB and AA, what type of interactions they have when in the pure state, same type of interactions if they are found in between A and B, two components of the solution, so then we call it as what? Ideal. Okay. So now what happens in another solution we will consider, where if A is having repulsive interaction, repulsive means A repel B, B repels A. So therefore what happens? Volatilization of the solution will take, takes place. Volatilization means both will evaporate fast and vapor form will be more. So therefore vapor pressure will be more than expected. So then it is called positive deviation. If the interactions are attractive interactions, A is more attracting with B or B is more attracting A when compared to AA and BB. So then what happens? One molecule will attract other and both will attract with each other. So because of that reason what happens? They will not allow, either A is allowed to escape out to form the vapor readily, or B is allowed to escape readily by the A. So these interactions leads to what? Decrease in the vapor pressure, hence negative deviation from the Raoult's law we are going to see. So see here, when they have like more affinity with each other, say for example water with all types of acids, generally they have more affinity with each other. So because they can form hydrogen bond readily and they are more readily solubilized and they won't allow one to escape the other. Okay, so therefore they show negative deviation. If the interactions are between polar, non-polar, two different liquids, if you mix, then what happens? Positive interactions we are going to see, or repulsive interaction will be there, and that repulsive interaction makes them to what? Repel with each other, to increase in the vapor pressure than expected. So hence they show the positive deviation. Now let us look into the options. Water, hydrochloric acid. As already I have mentioned, acids and water have very close relation. So they always have what? More affinity. They show negative deviations. Okay. So therefore your first option, third option. So both are how it is. So both are what? Negative. We'll see. Negative deviation they show. And acetone and chloroform. See here. Acetone and chloroform. It is very interesting. So this acetone molecule. Okay. So oxygen of the acetone molecule and hydrogen of the chloroform. What they will do? So they form the hydrogen bonding. So as they form the hydrogen bonding, what it leads? Attractive interaction we call. So as they show attractive interaction means what? It is also negative deviation. So therefore your right option is benzene and methanol. So why it is so? Benzene is what? You write the structure. Benzene is non-polar, whereas your methanol is polar due to presence of what? OH bond. So therefore non-polar, polar always what? Having repulsive interaction with each other. So as they repel with each other, they show the positive deviation. Hence your option is what? 2. Right? So let us move on to the next question. When you take equimolal solution, okay, means same amount of the solute, okay, solutions if you prepare in the same solvent, means say for example I have taken water, right, 1 kg of water, a total 1 kg solution are there, and both are being added with solute A, and here it is solute B is being added to the water to make molal solution, 1 molal in each. Okay, so now what is the question is, when you are adding same moles of 2 different solutes, okay, so then if you are preparing the same amount of the solution, equimolal solution, so then the number of components, okay, present in both the solutions will be same. So therefore leading to what? Same boiling point but a different freezing point. So always remember, boiling point will be elevated, okay, and but different freezing point, it's not possible. It is not like that, because both will be same freezing point but different boiling point, same boiling point and same freezing point, because so they show the similar type of elevation in the boiling point and depression in the freezing point. So therefore both the solutions will be as it contains the same solvent. So because of that reason, what happens? Both will be having same colligative property, that is either it is boiling point, elevation in the boiling point, or depression in the freezing point. Hence your option is 3. Okay, let us move on to the next question. 13th question. Well, there are 2 open beakers, one containing a solvent and other containing what? Solute. Right? One containing solvent and other containing mixture of that solvent with non-volatile solute, are together sealed in a container. See here, I will show you how it is. See, these 2 are the open containers. One is containing solution and another is just solvent. Solvent is there, right? Both are open now. Then what they are being done? They are being sealed in a single container. Both are sealed. Now, what happens to this that is being given in the options? First we will read out the options and then followed by that we will see which is the right answer. Fine. See here, the volume of the solution increases and the volume of the solvent decreases. The volume of the solution and the solvent does not change. Volume of the solution does not change and the volume of the solvent decreases. The volume of the solution decreases and the volume of the solvent increases. Now, your solution is being added with non-volatile solute. Okay. So therefore, when you add non-volatile solute, then leading to what? Lowering of the vapor pressure or vaporization will be reduced. Whereas here nothing is being added, it is a pure solvent. So therefore what happens? The vaporization will be what? Greater, vapor form will be more. So therefore what happens? Decrease in the volume of the solvent we are going to observe. Here as it is being added with non-volatile solute, so therefore there is no decrease in the volume. So therefore your option is what? C. The volume of the solution does not change and volume of the solvent decreases, right? So that is how you have to understand this one, right? The next is 14th question we will take. Which of the following aqueous solution has the highest freezing point? Okay, very interesting question. So now again it is abnormal molecular weight. So based on that it is. See, first option is your 0.1 molar sucrose is there. Sucrose means your sugar, right? So 0.1 molar, right? Sucrose means C12H22O11 is the molecular formula, right? Whatever it is. So it is a non-ionizable, or else we can call it as what? Non-electrolyte. Whereas 0.01 molar NaCl, we know that when you dissolve this NaCl, it will be Na plus, or it undergoes dissociation to give Na plus and Cl minus aqueous. So therefore 0.01 moles of NaCl will give 0.01 mole of Na plus, 0.01 mole of Cl minus. So therefore overall number of entities will turn out to be 0.02 moles, right? You should remember this. Then followed by that, the third option, 0.1 molar NaCl. So 0.1 molar NaCl means, so it is going to give 0.1 mole of Na plus and plus 0.1 mole of Cl minus. So therefore it turns out to be 0.2 moles of entities, right? Then fourth option is 0.01 moles of Na2SO4. When you dissolve, you will be getting 2 moles of Na plus and 1 mole of or 1 SO4 minus 2. So therefore 2 into 0.01 means 0.02 plus 0.01. So overall it turns out to be 0.03 moles of entities will be there in the solution. Okay. So now the question is, which of the following aqueous solution has the highest freezing point? Highest means greater freezing point. Greater freezing point will be of that solution which contains low number of solute molecules. Now this contains 0.03 moles of entities, and this contains 0.2 moles of entities, and this contains 0.02 moles of entities, and here it is 0.1 mole. Now which is lowest among these? The lowest is your NaCl, 0.01 mole NaCl. So hence it will be having highest freezing point. Second option will be what? For highest freezing point, and third option will be for lowest freezing point. If it is asked for lowest freezing point, then you should choose like this, and you should make a note of this. Okay, how we have to identify if it is an electrolyte, if it dissociates and gives how many entities, cations, anions, whatever it is. So that you should take into account, and after calculating that, you should check the number of moles of entities which is having highest, so that will show the lowest freezing point. Okay, and which is having lowest, so that will show the highest freezing point, right? So therefore your option is 2. You should remember this. Next, let us move on to the 15th question. When an electrolyte is dissociated in the solution, the Vent-Off factor I is, okay, electrolyte they are saying, and it is undergoing dissociation. First we should know what is this Vent-Off factor. Vent-Off factor is equal to, it is the ratio of number of moles of entities after dissociation. Okay, dissociation divided by number of moles of entities before dissociation. Okay, before dissociation, right? So therefore, number of moles of entities after dissociation, already we are saying it is greater. So therefore, if the numerator is greater, high, so then compared to denominator, okay. So meaning is what? Always remember, your value will be what? I value will be greater than 1. So therefore, your option is fourth option, right? Equal to 1 means what? Equal to 1 means there is no dissociation, it is a non-electrolyte. Then less than 1 when the number of entities after if it is undergoing association, then it will be less than 1. If it is undergoing dissociation, always it will be greater than 1, as I have shown here, right? Let us move on to the next question. 16th question. So which of the following is not colligative property? Already I listed in the previous question that what are the colligative properties are there. Elevation in the boiling point, depression in the freezing point, osmotic pressure, and what? Relative lowering of the vapor pressure. Relative lowering of the vapor pressure is not there, and optical activity is given. This optical activity is not is a colligative property. You should remember this. 4 if you remember as colligative property. Other than that 4, if you get any other option, so then that option is said to be what? Not a colligative property, right? Fine. So next we will move on to 17th question. The Vent-Off factor I accounts for extent of dissolution. How much it is being dissolved? No, it is not going to tell about that. Extent of mobility of the solute? No, mobility of the solute is not relevant with your colligative property, right? Then extent of solubility? No, it is also not that one. Extent of dissociation? Okay, so Vent-Off factor I depends upon extent of dissociation of the solute as well as extent of association. Okay, so as if the option is given association, then that is also correct. Okay, solubility, mobility, dissolution, these are all not the factors on which your Vent-Off factor is not going to depend. Either dissociation or association, or if it is given both dissociation and association, then it will be the correct option, we can say. So therefore your right answer is what? Fourth option, that is extent of dissociation of the solute, right? So let us move on to the next question, that is 18th question. Isotonic solutions are having the same, okay. So one thing you should remember, what is osmosis? First we will define. Osmosis means movement of the solvent molecule from what? Dilute solution to concentrated solution through semi-permeable membrane. We call it as what? Osmosis, right? Now if the concentration of both the solutions are same, then there is no net osmosis, we call. So therefore isotonic solutions are having the same what? Osmotic pressure, okay. So that how you have to answer. Why it is having same osmotic pressure? Because concentration on either side is same. So therefore the movement of the solvent in this direction and movement of the solvent from this direction, both will be same. So when it is same means what? Osmotic pressure is also same, right? So let us move on to the next question. A solution of two liquids boils at temperature more than the boiling point of either of them. Hence the binary solution shows, okay, two liquids boil at a temperature more than boiling point. Means, so as compared to their boiling point, they are boiling at higher temperature. Okay, meaning is what? First you should define what is this boiling point. Okay, so let us define the boiling point. See, if you take a liquid, it is being covered with vapor pressure. When this vapor pressure becomes equal to atmospheric pressure, then the temperature at which this happens, that temperature we call it as what? Boiling point. The temperature at which the vapor pressure of the liquid becomes equal to atmospheric pressure, okay, then it is called boiling. Now the boiling point is high, meaning is what? Initial vapor pressure is low. Initial vapor pressure is low means what? It happens due to what? Due to association of the molecule in the solute molecule in the solution. So therefore, or associative interaction of a binary solution. So leading to what? So that is because negative deviation from the Raoult's law. Okay. So as it undergoes negative deviation, because of that reason, what happens? They will be having higher boiling point than expected. Okay. So that is how you have to answer for this question. And last question we will take, 20th question, and that 20th question is, cooking is fast in pressure cooker because, okay, applied type of question is there. Food particles are effectively smashed. Of course, it is being smashed perfectly fine, but that is not the reason why it is going to happen fast. Okay. Water boils at higher temperature inside the pressure cooker. Food is cooked at constant volume. Loss of heat due to radiation is minimum. Right, we will go to this. As already I have mentioned, if you raise the vapor pressure of any liquid to atmospheric pressure, then that liquid starts boiling. Now cooker means what? It is being completely sealed. Okay, it is acting as an isolated system. So therefore, whatever the, after when you start heating, whatever the vapor is formed, that vapor is collected there only. It is not allowed to escape out. So therefore, what happens? Immediately it will reach 1 atmospheric pressure. Okay. Even if you give small amount of heat energy, that is enough to bring this vapor pressure equal to 1 atmospheric pressure. Hence, what happens? Water starts boiling at high temperature. Water starts boiling early. So by that, what happens? The temperature due to the presence of the vapor form and boiling of the water increases in the this cooker. So therefore, what happens? The boiling of the food occurs, or cooking of the food will be faster in the case of what? Pressure cooker. So therefore, your option is 2. Okay. So this is how we have taken covering all the different topics of the solutions. 1 or 2 questions we have selected. Beyond this, even you can go through other simple examples. And one thing you should remember, the questions will be simple, and 1 question will be applied, 1 will be memorizing type of question will be there, and 2 questions anyhow you are going to get on this 1 mark questions. Fine. So I hope you have understood all these concepts. Wherever it is required, I have explained the concepts already. I have been said to you people that be with us till your board examination to achieve mission 70. Okay. Thank you for watching. Okay. Please subscribe our channel and inform to your friends also to subscribe. Fine.